All right, thank you very much. Well, you've all been greeted extensively this morning, so I'll just go ahead and introduce myself. Happy to see a few friendly faces, and I'm not just talking about my colleagues. So, my name is Gerard Kraus. I've got about 18 years experience in the chemical water treatment business, but recently came across to Xylem as a business unit manager for treatment. Now, when I hear treatment, first thing that comes to mind for me is medical treatment, which I'm sure we've all been exposed to, unfortunately, in one way or another. And medical treatment, you've got an undesired, unhealthy status, which is being treated by experts, such as the doctors, nurses, and pharmacists, through the use of medicine, technology, well-known treatment methods, and all this and that, to change the status to the more healthy, more desired state. And that is exactly what we at Xylem do with water, obviously. So yes, in treatment, I'm not going to steal the thunder, but we as Xylem, we've got the technology, we've got the expertise. We also make use of partners. You heard previously about our partnership with SA Water, and today we will have the signing ceremony to welcome SA Water as an installer for our Leopold filter floors, as well as provider for packaged water treatment plants. So also thank you very much to you guys for being here. But without any further ado, can you please welcome to the podium our international guest speaker from Xylem. He's been with Xylem, I believe, for about 18 years, but an extensive world traveler, lots of experience within water treatment, within selling into the international market, and he hasn't accepted it yet, but Africa is the toughest part to sell to, so hopefully he can convince most of us. So without any further ado, please welcome Tony Callery.
Buenos dias, senores. Como que va? What a showcase. So I don't know what I did wrong, but somewhere in my career recently I must have made some major error, because they pulled me out of 8 years in Latin America and sent me to South Africa and worse, to Australia. So, I've got about 32 years international experience in water, and about 8 years military prior to that. Of course, that was all overseas. And I want to thank Madam Swart and Dr. Barnard for their discussions this morning, because it's exactly the situation we've been preaching since about 1980. And later in the day, we're going to have a more lively discussion on reuse. But I've been asked to spend a certain amount of time this morning to discuss portfolio for treatment that is available through Xylem. So please feel free to stop me anywhere along the line of this discussion. I'll try to hold down a half hour or 45 minutes. There's going to be areas in here that you may want to discuss more in depth, and feel free to approach during the break, or see my colleague here, Gerhard, and let's have an appointment. I will be here for the next 2 weeks. I come to South Africa, Sub-Saharan Africa, about every, what I've been averaging, about every 3 months now, I guess, more or less, every 3 or 4 months. I'll apologize for my accent in advance. So like I said, if you have questions, please ask them. So, when we talk about Xylem, I'm going to skip through some of this because you've been hearing it all morning anyway. But when we talk about Xylem, what we're trying to do is take a look at advancing the smarter use of water. So we heard Madam Swart's discussion of precautionary notes about building systems that suit the operating environment, and the necessity for mentoring skill levels for operators that continue to operate these plants. Yeah. Is that better? Everybody hear me right? Okay. And that's one of the things we're very interested in doing. I've got a vested interest in this myself. first treatment plants I built were USAID projects back in 1978 for a company by the name of Bill Harvard Construction of Birmingham, Alabama. In some very remote parts of the world. Some of those remote parts of the world were pretty lively at that particular time, back in the late 70s, early 80s. And so we learned early on that build plants in areas other than central United States and Europe weren't necessarily involved with an interpretation of best available technology being the most experimental technology available on the marketplace. Best available technology, to me, interprets as having the best available technology that suits the environment and the future development of an area and allows operators to train up on the equipment and advance their own skill levels. Thank you. So, and one of the reasons I work for Xylem today and have been with this company about 24 years in one capacity or another, under one name or another, is simply because they have the attitude to allow people like me to stay within the organization. Respect, responsibility, integrity, and creativity. And creativity is a big deal with us. Creativity means we understand the situation apparent in the area and deal with it. So these are all covered earlier this morning. Water scarcity, environmental issues, aging infrastructure, population growth, urbanization, energy consumption. These are all issues that we deal with every single day now, both in the municipal market as well as the industrial market. And where we see this in the industrial market is primarily in high water usage industries, mining, which should be near and dear to heart to everybody in South Africa. Pharmaceutical business, cosmetics, and what they also refer to as chem pharma, oil and gas, which we see in some other parts of the world, and of course food and beverage. The interesting thing about food and beverage is most beverage manufacturers today, whether they're international or local, are very, very concerned with their whole issue of water scarcity, environmental issues, and their social license to operate. And we'll talk about that more when we get into reuse. But just as a rule of thumb, beverage manufacturers today, in most parts of the world, are trying to reduce their usage of water from 4 to 5 liters per liter of product to 1 liter fresh water per liter of product. In other words, they want to reuse water to the level that their only fresh water usage goes in product. It's a highly ambitious goal, but if you talk to the majors, they're all trying to do this. Okay, so we basically work across the entire cycle of water. We don't do it as well as some people would like us to do. We tend to be rather specific about segments within that cycle, and we'll talk about that a little bit too. And this kind of demonstrates it. These are business segments for Xylem, so you get an understanding of how we really operate. And as you can see, we have 3 areas within the company: water solutions, analytics, and applied water systems. Okay, we all operate together, and we all operate separately as well. Water solutions is the one you'll hear more about. Yeah, that's where we're based out of. This is our breakout of our business structure. As you can see, industrial is a big piece of what we do, and public utility is the other big chunk. We do some residential, some commercial, and then some agricultural as well. And then these are our breakouts of operating areas. South Africa is included in Europe, by the way, just with construction. Whether that makes a lot of sense or not, it is. Okay. So, and well, I take that back. Here we are. They broke it out in this particular one. But normally it's considered under part of EMEA. And then this area, as you can see, is Latin America, Middle East, Africa, and Canada. Okay. All right. 20% of our revenues are generated in emerging markets. Emerging markets in this definition do not necessarily mean emerging economies. We're a little self-centered, So emerging markets to Xylem means markets where Xylem has not been particularly active in the past. Okay. This gives you an idea of office footprint. As you can see, we're pretty widespread. And you can see we have a number of offices down here in South End. Okay. These are our companies. And this is some of our customer base here. Okay. Godwin, which was discussed about for dewatering. You start to take a look at the treatment side. You're seeing Wedigo, Flight Mixers, Flotronics, Javsco. You've got Leopold Sanitaire. And so what we try to do is find the optimal solutions using product capabilities and processes that we have available as a corporation. Right? And this is oftentimes a challenge, as you can well imagine. So if you take a look at the infrastructure overall, about 73% of our income comes from the transport side of the business. 18, it's actually about 20% now, comes out of the treatment side, which is very specific treatment of these three brands. And then 9% comes out of the analytics side. Okay. So again, it gives you a pretty good idea how we operate. All right. Building services, industrial water, irrigation, and then of course, this is the applied water side. And then when you look at it overall, these are the areas we deal with. So what does this mean to you as operators or designers or contractors? What does this mean to you across the whole cycle of designing, constructing, and putting the plant in operation? Well, I'll get the shed. You've got pumps and controls, you've got aeration, you've got secondary biological, you've got filtration, ultrafiltration, desalination, disinfection, oxidation, monitoring and control. But don't you have there, well, we don't do mechanical screens, all right? But we can put those in the system. But everything has to do with the process control of a plant, be it water treatment or wastewater, be it industrial or municipal, we can design into it. Okay. This is processing, wastewater treatment and reuse, and we've tried to concentrate on those parts of the process that are integral to the actual operation of the plant to achieve a given quality of water based on the parameters of the influent to achieve the goals of the client. All right. Not what we think the goals of the client are. Well, at least hopefully we don't design for that. We try to design for the goals of the client themselves, and not necessarily just what the client tells us. We try to work with the client from a design perspective to give them what's really required and give them a number of options that suit his economics of the operation, his future plans for the operation, and the needs of his constituents and we're going to have stakeholders. Okay, so we got the capabilities to do this. Range of reuse, we'll talk about it a little bit. I'm going to skip kind of through this. I mean, these are why we think you ought to work with us. If you haven't worked with us, you don't have a reason to work with us. You know, it's worth giving it a shot. We try to combine product and process knowledge and provide that as a total package. Okay. But the first thing we always want to know about is what's our water source? What are we dealing with? You know. 2008, built the first reuse water plant in Peru. Absolute first one. Lived in Lima for 2 years doing that. And it was a little place called Manchai, and the water source was supposedly domestic sewage. And they were going to reuse the water for agriculture. And that part of Peru is very arid. And so all water has to be reused. Under Category 3 laws in Peru, that has to happen. What is my water source? Okay, domestic sewage. All right. Tends to be a little stronger than you see some other places simply because they use less water. So we built the plant, 90 cubic meters, expandable to 125, and then found out that they had never hooked up the collection system for the plant. So we had to wait a year. Built the plant and sat on it for a year until they put a collection system in. Okay, very important to know what your water source is. Impounded water supply is good, seawater, lagoons, rivers, sewage, industrial makeup, whatever. We need to know that. Okay. We care a lot about water characteristics, as you do as well, but when you start looking at plant design, one of the things, this is just an example of looking at TOC ranges in natural waters, and you can see how they differentiate. Swamps are interesting to work with, by the way, as a water supply. That's usually a membrane plant. Okay. The second thing we need to know is precisely what is it you want to do with the water. Now you can come to me and say, well, we have to meet this water quality restriction. And that's fine. We're happy to do that. We're going to ask you another question about that. We're going to say to you, okay, once you meet this water quality, exactly what is it that you want to do with the water? And now we're talking reuse. We do a lot of work in reuse. And one of the areas we do a lot of work in reuse in parts of the world is taking wastewater to a revenue stream. All right? Anybody do that? Anybody do that here? Anybody sell their wastewater? No? Works real well if the law permits it. In many parts of Latin America, you can't do it. Constitutionally, you can't sell water at all by rights, which makes it difficult to pay for treated water. But in Brazil, for instance, a major water treatment company in Brazil is called Sebasp. Sebasp, Sebasp, and they sell boutique waters. They produce from wastewater 3 different kinds of effluent water that they sell back to industry at different price levels, depending on what's required. And they do this successfully. Now, Brazil, of all of South America, is probably the least arid place you can go. They got lots of water. Lots of fresh water. Problem is, most of it's polluted. All right? So the water that they can reclaim from wastewater and sell back to process for industry is highly worthwhile to those process plants. And we're talking oil and gas plants, we're talking pulp and paper mills, we're talking textiles, we're talking all kinds of things that require water process. And they actually reuse their own water as well, or they sell their wastewater to Sebasp and then buy it back, treated. Okay? So if you're not selling wastewater, and you legally can sell wastewater to create a revenue stream, it's worth looking at. Does this fall under any regulatory activity? No. Okay. All right. It helps finance your treatment, your growth. Okay. But whether you're going to use it for irrigation, whether you're interested in using it for process, whether you're interested in reusing water back for potable supply, or taking fresh water and cleaning it up for potable supply, what's your long-range plan? Everybody's got to have a long-range plan. It can't be, I want to meet environmental standards today. What's that get you? That gets you today. All right? So talk to us. So if we have a complete understanding of raw water composition and treatment targets, we can choose right technologies out of the treatment portfolio, or, and what we have done on occasion, is recommend somebody else's technology to you. Done that before too. All right? So we try to be fair about this. So, just quickly run through some kind of product end of it. If you're talking about drinking water, you're talking about clarification followed by filtration followed by disinfection. Now, that may take a lot of forms to get to that point, but we're just going to talk about them in a general sense. So one of the things you get involved in when you talk about clarification is dissolved air flotation. And these systems were designed originally by Leopold to meet an issue that hadn't really been addressed very much prior to that point. And that issue primarily was, what do you do with impounded water supplies, reservoirs, even seawater, that has to deal with algal blooms, which cause you a tremendous amount of problems when you're trying to filter water. Now, you don't see cleared out, you don't see air flotation being used on river water sources. You don't see it being used on high turbidity sources. But impounded supplies that are high in organic load lend themselves very economically to using dissolved air flotation. Okay. Why do you do that? Because instead of adding chemistry, because now remember earlier discussions talked about overuse of chemistry, and flocculation is a place where you see a lot of overuse of chemistry. Instead of bothering with adding a lot of chemistry to get gravity settlement, where you're dealing with hundreds of micron sizes, you float it off in the tens of micron sizes. And you say, well, that uses a lot of energy running that blower, because you do have a blower on there. But if you look at life cycle cost, it pays off in a relatively short period of time. Okay. So where do you use them? Algae-laden waters, cold and difficult to flocculate waters, assuming it's quiescent. Okay. So these are very popular in the north. Filter backwash recovery. And you say, well, why do I want to bother with that? Why do you want to bother with backwash recovery? Well, because it's a source of water. Turns out it's actually cheaper to recover it than it is to waste it out. Open intake RO pretreatment. There's an application of desalination. Highly colored waters, because they tend to be organic in nature. Low to medium turbidities, yeah, we said that. And the other one that they don't mention here is if you're running facultative lagoons for your wastewater, and you've got a tertiary settling pond out there, you can use this to reduce your BOD level and also improve your quality going to effluent. You improve your quality going to effluent, what can you do with it? You can reuse it. You can bring it back. You can run it through UV. You can do all kinds of things because you've actually put a filtering stage. You've done this becomes a tertiary filter for a facultative lagoon. Very worthwhile to do. Done these in Brazil. They have a lot of lagoons. Okay, less volume of sludge to handle. Why? Why do you have less volume of sludge? Well, because you're floating it, and you're going to skim it off the top, so you're going to skim it at about 5% instead of the usual 0.5%. No chemical cost to speak of, lower energy usage, less filter waste. Very worthwhile to look at if you got a quiescent stream. Okay, that's what it looks like. You got two stages of flocculation up there. Here's your aerating chamber right here. So what's one of the big advantages about this? You say, well, it can be pretty costly, but you know what? You mount these things in concrete. And the commitment we'll make to you is we'll build the saturation tank, the effluent laterals, piping and hardware, everything except the skimmers and the air systems here and our top entry mixers that will provide flight. We'll build all the hardware we can locally. Y'all pour the concrete. We'll help you start it up. Makes it very cost effective. Okay. But there's a lot of quiescent supplies in South Africa that can benefit from this type of technology, and it is available, and we'll work with you to design it. I promise I'd kind of skip along here. Okay, so everybody's seen this chart at one time or another in your career, I'm sure, because this is the classic discussion of, do I use media filters or do I use membrane filtration? And everybody's seen this, and it comes down to the fact that in the case of membrane filtration and media filtration, it's all okay, but we're dealing with a mechanical process here. So basically, all you really have to do when you're dealing with a comprehensive analysis of mechanical processes, say, what's the most economic for me to run based on the water quality that I've got to deal with and the quality effluent water I require. Okay? That's the only decisions you have to make. And then it becomes very simple to decide what technology you're going to use. Yeah? Okay. So, what's available? Gravity media filtration. Near and dear to my heart. I actually worked for these guys for about 8 years at one point. I was always real surprised when ITT bought them and I wound up working with them again. Generally speaking, where you apply these is in larger filtration systems. All right? More specifically, potable water or desalination pretreatment or tertiary filtration for wastewater or for denitrification. 4 areas and you're done. That's where you look at it. Okay? What's the key here? Okay? Now you know Leopold primarily from the underdrain systems, and got a bunch of them showing up here up the road here, and got a whole new one that's coming out that was basically designed to make it easier for contractors to install. We're going to talk a little bit about the ins and outs of the underdrain, but here's my cautionary note. Is the underdrain system the most important part of a gravity media filter? And the answer is, oh no, absolutely not. What is? And the answer to that question, nobody's going to raise their hand on that one? The answer to that question is the media itself. And you want to be very, very specific about that media. Now, one of the skills Leopold has that doesn't talk about very much is the ability to determine the type of media required for the proper filtration of any source of water within certain turbidity ranges. Okay. Talk to us when you start talking about media. Don't do what they did to me in Veracruz, Mexico, where they said, we're going to buy the media ourselves and we're going to absolutely follow your specifications. Called me up 3 months later when the filters blew up and said, it's got to be the underdrain. It's always the underdrain. And basically what they had done was the mayor's brother-in-law, who owned a sand company, loaded the filters up with beach sand. Beach sand doesn't work as filtration sand. He put a layer of anthracite on top of it, which we had recommended. Only use feedstock anthracite, which means just raw stuff. Threw that in on top of the filter. So you want to be very specific about your media load. Very specific. Now, what Leopold offers you to go along with that is the expertise between determining whether you want to be able to do biological growth, whether you're doing mechanical filtration, whether you're actually going to do absorption on the filter media. You know, these are very worthwhile discussions to have. And then they're going to talk to you about the advantages of dual parallel versus single pass systems. And I'm not going to get too carried away here, but you can see the discussion here, actually, pictorially. The problem with single pass units, of course, is physics. It's hydraulics. And you're going to get more water coming out the back end of the lateral than you're on the front. All right, what's that mean to us? Well, when I backwash a filter that way, that means the back half of my filter is going to get clean and the front half of my filter is not. It also means that when I'm collecting water through the system, it filters down through the media. because I got a cleaner filter in the back, my throughput through that part of the filter is going to be much higher than other areas of the filter, which means I'm not going to optimize my media. And when you don't optimize your media, what happens? You get breakthrough. When you get breakthrough, Madam Schwartz crew is going to come around and do an evaluation on your blue drop, and you're going to lose, all right, because you're not going to have your water quality. So you want to have uniform distribution and collection across the filter at all times, and dual parallel designs give you that. They have balancing laterals, okay? That's what all this is about over here, okay? And again, we can get into those discussions a lot more in depth. I'm just trying to give you a quick overview of what's available. And this gives a discussion on why that works this way. As you can see, this is a classic nozzle system over here. And this is a classic TP arrangement over here. And as you can see, you have dead spots that form up in between headers. You've got dead spots. What's the big problem with dead spots? Well, we used to talk about mudballing all the time. Then as regulations tightened up, we began to realize that giardia and crypto accumulate there and never, ever, ever leave your filter. Never, ever. Because it doesn't get backwashed. Right? So your filters can go septic. And we've seen that happen far too many times. And this gives you an idea of distribution through the system. Okay, that's just history of the drain. Okay, now, one thing I want to touch on. Well, I can do this after we talk about desalination. Okay, so one of the applications for filters we discussed was desalination. That was one of your 4 application points for gravity media filtration. Desalination applications. Why? Why do we care about pre-filtration on large desalination plants? Now, is desalination an issue in South Africa? You bet. There's probably 20 to 25 projects either in design or getting close to approval for desalination in South Africa. That's a lot of projects, big projects, not little projects. Big projects, 1 million gallon a day, which is meters. I can never remember what it is, cubic meters. 3.8 cubic meters per second. Yeah. Oh, well, yeah. So big plants. What do you use? Anthracite sand. You're looking at 8 to 10 TDS. Well, I'm sorry, 8 TN turbidity, actually, coming into the filters. What it'll deliver, and this is the big deal. This is the big deal. Delivers 2.5 to 2.7. After the filters are ripened in. But the most important thing is SDI performance. You want to get SDI under 3. Okay, these will deliver. These filters often with a DAF. Why would you put a DAF on a desalination system? Algae blooms. You don't have problems with harmful algae blooms off the coast? Don't worry about it. You run a beach well? Don't worry about it. You don't need DAF. Okay. Desalination applications. Now, 60% of Leopold's business is rehabilitation. And of that, the majority of rehabilitation filtration systems takes place with false flow arrangements. Okay. Very easily retrofit, very quick, very clean, better performance, guaranteed better performance. And as you can see, 80% removal in TSS and 80% removal on BOD5 as tertiary filter. Run deep bed sand. All right, this is the case study. Okay. This is removal of plenums, demolitions, modification of air systems, repair the floors, set the laterals,
Boom, 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 4 days, you're done. Okay? Very fast. Better operating facility. And we're not going to go through it here. This is a denitrification filter. Denitrification, how do you set up a denitrification? Well, denitrification filter comes off secondary process, wastewater, which we're going to talk about here in a little bit. You add a carbon source like methanol, molasses, whatever. Any carbon source will do. And you can denitrify within a filter. You can actually operate a biological filter. You want to get real classy about this for reuse, you can add ozone to the mix. Go to biologically activated filters or flooded filters, and now you get COD removal as well as oxidation in the system. Okay? A lot of things you can do for tertiary treatment that will not require you to build a whole new wastewater treatment plant. Take what you got and work with it. Okay? Now, 10 minutes and I'll wrap it up. Okay, we'll get into biological a little later. Okay, so clean water treatment, RO systems, UF systems, membrane systems. Why do you do this? Why do you do this? Because when you look at membrane solutions for clean water, you're basically dealing with one of these two arrangements. Okay. In all cases, whether you're dealing with membrane systems or you're dealing with media systems, your biggest concern is how do you pre-treat? Okay. Biggest concern with gravity media filters is what do I do when it rains really hard in the wintertime and my turbidity in my river that I'm pulling my water from jumps from 300 to 2,000. What happens when my TDS goes up like that? How do you deal with that? Okay. That's a tough question. Really is. Because you will foul your filters. There's no magic solution to that question. Upflow clarifiers work pretty well. You will usually recommend somebody else's. You can also do some kind of quiescent tankage if you got the space. But it's very, very important to get your TSS down to something you can deal with to reduce your chemical cost. So when you have those high spikes like that, you want to have some type of mechanical device. Remember, this is all mechanical. This is all hydraulic. Nothing magic here is. You want to have some kind of means to drop your high turbidity loadings, your high TSS loadings, before you go into your flocculation. A lot of people don't do that. They deal with it by increasing their chemistry load. This screws up your system. Okay? So, when do you want to use membranes as opposed to gravity filtration? Smaller facilities. Smaller facilities. Or, I need a small footprint, and I got a high throughput. I don't have any space. Or, I have existing filtration basins, but I want to go to membrane application. Can I retrofit into those basins? Yes, you can. Absolutely. Can I don't have a big problem with really high turbidities coming in. Can I take my flocculation basins and put in maybe ozone and ultrafiltration? Yes, you can. Okay. If that's your best solution. Because one of the advantages membrane solutions actually have is that they're not real complicated to operate. And you can take novice operators, train them to run membrane plants, easier than you can train them to operate a gravity media plant. Now I know that sounds like heresy, but it's true enough. And that is the coming future of water treatment. Why? Because by using membrane solutions, you vastly reduce your disinfection potentials. Yeah? Remember, it's mechanical filtration. If your microbe or your biological constituents or water supply can be physically removed, you're better off done with UF and RO or some combination of membrane. Because it reduces the amount of residual chlorine you need to feed to the water to meet your residual levels. Okay? That's one of the reasons on gravity media filters, sometimes we use ultraviolet directly after the filtration process and then contact chamber for chlorine. Because it cuts your chlorine usage in half and still maintains your residual in line without any impact. Meeting regulation. Okay. The other thing is, we deal with this a lot in South America, for instance, and other parts of the world where they do a lot of livestock and agriculture. And that's helminthova. I don't know, does that hit the radar down here yet? Helminthova? Yeah, okay. Helminthova is a killer. All right, make you sick, real sick. Passes through digestive tracts of animals, winds up in the water supply, does not reactivate out of the amoebic stage until it's back in the human system, makes you deathly ill, and then when it's discharged from the body, it goes quiescent again until it's taken back up by animals and redistributed. Okay. Nasty stuff. But can be removed with membranes, can be removed with gravity filtration. Synthesize do that. So if helminthova is an issue on your wastewater plants, and you're discharged into a regulated stream, the simple addition of a tertiary filter to your biological system will take care of that problem for good. All right, as long as the system's maintained. You can remove helminthova, and we've proven it time and again through either membranes or gravity filtration, deep bed medias. Because chlorine doesn't touch it, UV doesn't touch it, ozone won't touch it. The only thing you can do is filter it. And then, when you pull the sludge off, destroy it with heat. You can do a thermophilic process, which also stabilizes your domestic sludge, which you can then take and redistribute to the agricultural climates. So it's a good situation all around. Don't have to landfill it, and you don't have a hazardous landfill at that point. Okay. So, PCI, these are certain types, these are very specific types of membranes, mostly for color, brackish water treatment, and also some very, very, very specific applications in industrial applications, pulp paper being one. Okay, and then industrial wastewater treatment systems. So, what I'd like to do, so we get back on time frames, I'd like to cut it off here and finish this discussion in the afternoon session. And I would really like to get some participation from you on that, because I want to talk about applications for biological systems. Because you'll see here in our offerings, you know, we do all kinds of potable water systems, containerized influent, desal. We use some GE membranes in particular applications, plus others, depending on what the situation is. We act as an integrator. And then we also produce, and what we'll talk about as we move on, we can talk about effluent quality if anyone wants to have that discussion, which we will. Okay. And this was our upgrade with membranes we talked about, set right down in the basin for filtration. And then we can talk at great length about all these things. So for the afternoon session, we're going to start with talking about activated sludge applications. Okay. And so my question to you, so I'm better prepped for that afternoon discussion, is conventional activated sludge a common application here in South Africa? We got wastewater operators out there. How many of you guys run the standard CAS system? Do we even need to talk about wastewater this afternoon? Do we have anybody here who cares about wastewater? Yeah. How about SBR type systems? You guys using batch reactors?